Now that we've created a push at index function that adds a node at a particular index on our linked list, I'd like to create a print function that will print a node at a particular index. Currently, we have a print function that prints every node on our list. But what if we have a million nodes? Do we really want to print all million of our nodes? In some situations, yes, but what if we just wanted to see a particular node that we had added at a particular index? For this video, that's what I would like to do. Create a print function that prints at a particular index. The first thing that I'd like to do is create a function prototype. This is going to be a void data type, and let's call it print index. And we're going to take on two parameters. We're going to take on a node star head, and since we're not modifying anything on our linked list, we're just going to use a single pointer, and then the second parameter is the index that we would like to print. I'm going to copy this and put it at the bottom to create a function definition. This function will be very similar to our push at index function in terms of how we traverse and stop at a particular node. On the right hand side is a pictorial representation of our current linked list, and the data are 10, 20, 30, 40, and 50. And let me print that for you. So 10, 20, 30, 40, 50. In the blue, on top of each node, is their index location. So this is index 0, index 1, index 2, index 3, and index 4. And so what I'd like to do is I'd like to create a variable that will hold these values. And since I have index in our parameter that determines the location of what index we want to print, I'm going to use a different variable, and I'm just going to call it I. We're going to have that start at 0 since this starts at 0. And like the push at index function, I also want to create an integer variable called number of nodes. To do that, we are going to use the count nodes function. And here we're going to pass in head. And we are going to use this numNodes variable to set the bounds for our nodes to make sure that the index being requested to be printed is not out of bounds. Finally, I'd like to create a current pointer that will do the traversing, and then we're going to set that equal to head. In our main function, we have a head pointer that is currently set to null. If that's the case, then that means our list is empty. Let me target that condition. So if our head is null, then we just want to print the list is empty. The next condition is, what if the index being requested is out of bounds? And so I'd like to create an error check, which will use our numNodes variable. So how do we know if the index being requested is out of bounds? Well, if it's less than 0, then that would be out of bounds. But if it's more than the number of our nodes, and in this case, 5 nodes, then that would also be out of bounds, because our function will print index 0, index 1, index 2, index 3, or index 4. But if the user requested to print index 5, then that's out of bounds. Let's type that logic in. So what we want to do is we want to say if index is less than I, which is 0, then that's out of bounds. Or if index is greater than the number of nodes. So let me draw this. Here we have our I, and here we have our numNodes. So our I starts at 0 and our numNodes starts at 1. On our push at index function, we had index at -1. Here that's not necessary because we're not inserting a node once we stop. So for example, we stop at 1, we're not inserting a node in between 1 or 2. So we just don't want our index to be greater than where we want to stop. Let me just type in printf, and again I'm going to use two new lines to make it pretty. If the request for a particular index is out of bounds, it's just going to print out index request is out of bounds and must be in the range of 0 and 4. So let me explain this logic. Logic-wise, our index starts at 0. So if anything less than 0 is out of bounds, and anything greater, because we can only print out up to 4, then our index is out of bounds. So now let's go ahead and write the condition that will traverse our current and have it stop at a particular index that we want to print. So on the right hand side, I went ahead and created an activation record on the stack for print index, we have a head pointer, and this head pointer will take on the address of the head that is in main. And we also have a current pointer that we created on line 319, and they are currently pointing and holding the address of 0x100. So the way we want to do this is we want to traverse current. Let me demonstrate that. So say for example that the user requests index 2. So what we want to do is we want to say that while current does not equal null, as long as it's not null, because if current is null, because it's pointing to the same position that head is pointing to, that would mean that we have an empty list. So that's the first condition that we want to type, is if our current is not null. So here we want to type else, since this is our last condition, and we want to use a while loop since we're doing a traversing. So we want to say while current does not equal null. So that would mean that our list isn't empty. And then we want to use and. We want to say our index does not, this I in the blue, does not equal the index that we requested. So if we requested index 2, we want to make sure that I does not equal index 2, since I starts at 0 and index starts at 1. And I'm going to put this in parentheses, I does not equal index. Let me explain this condition. Index is at 2. Currently I is at 0. Current does not equal null, so that's a true statement. And I does not equal index. That's also a true statement. If that's true, then we want to traverse our current to our next node. So let me type that in. And as we traverse our current to the next node, we also want to increment our I, because our I is now at 1. So we want to do I plus plus. So now our I is at 1. So let me add that I plus plus. And again, the index we requested is at 2. So as long as this does not equal, let me start from the beginning. 0 does not equal 2. That's true. So we're going to go to our next node. And then we increment I. 1 does not equal 2. That is true. So we're going to go to our next node. So we increment 2. Current will be pointing at 2. 2 does not equal 2. Well, that condition is false. And once that condition becomes false, we exit out of this while loop. And this is where we want to print our node. When we are printing our node, we actually want to print the data. In this case, the data that index 2 holds is 30. Finally, outside of this else statement, I just want to print the number of nodes that we currently have. Okay, and this ought to do it. So now let's test our condition. Print at index head. Let me comment these out. Let's test our first condition. And let's just print index 0. This should give us the list is empty. So let me compile this to make sure that there isn't any errors. Oh, I forgot the semicolon here. Let's try it again. Oh, I forget the comma right here. And so the first I is for this format specifier, and the second, the num nodes, is this format specifier. I forgot the parentheses here, printf. All right, hopefully this will do it. Okay, the list is empty. Num nodes, the list is empty. So when I execute our function, we're getting this num nodes, the list is empty. And this is actually coming from our original print list function. And let me add a new line at the beginning, so that will fix that. So if I do that, that should fix that condition. There it is. Let me uncomment these. Let's test our out of bounds condition. So let's do -1. The index request is out of bounds. Must be in the range of 0 and 5. Number of nodes, 5. Again, let me fix my print formatting. Let me add a new line to the number of nodes. There it is. It's a lot better. So let me try to push it at index 5, where we are still out of bounds. And I get an error. And let me figure out why. Let's go back to our function and take a look at what we have going on. This is the error. So this condition is fine, But here we actually need to subtract 1 to it because our number of nodes, again, starts at index 1 and our I starts at 0. So I need to put a -1 here to match our index. And so let's see if this works. There it is. Because our number of nodes is currently, we have 5. And our index starts at 0. So we would need to match for our error check to make sure that our number of nodes matches our index. So now that we have this condition fixed, let me go ahead and test our other conditions. And let's print index 0. And there it is, 10. Index 1, 20. Index 2 is 30. Index 3 is 40. Index 4 is 50. So now let me comment out this print list function. Let's test all our conditions. Should be out of bounds. Index 0 should be 10. Index 1, this should be 20. Index 2 should be 30. Index 3 should be 40. Index 4 should be 50. Index 5 should be out of bounds.
There's actually a semantic error on my out of bounds and the way it's printing. Let me compile this again. Index request is out of bounds must be in the range of 0 to 5. While we do have 5 nodes, our indexes should only be from 0 to 4. So let me fix that. So here in our function, notice how we have num nodes -1. Well, when we print it, this also has to be num nodes -1. And again, the main reason is because our index starts at 0 and our number of nodes starts at 1. And so we have to match the index and the num nodes. So let me see if this is correct. And there it is. Index request out of bounds must be in the range of 0 and 4. And let me actually make range more specific. Let's add must be in the index range of 0 and 4. Must be in the index range. So that makes more sense.